This is the first in a series of short little screencasts on the photoelectric effect. So this first one we're going to talk about the experimental setup. So here we go. So the photoelectric effect experiment. The arrangement is we've got basically this glass tube which has had all the air, or nearly all of the air, evacuated out of it. So it's as much of a vacuum in here as possible. And we've got two electrode plates, or two metal plates. And these metal plates are connected via a circuit out here, and they go through an ammeter. So this is an ammeter designed to measure the current. In fact, what it's designed to measure is a current, any current created if electrons jump the gap. So what it's really measuring is the photocurrent. So in other words, the current that would be created in this circuit would be due to any electrons knocked out by incident light striking this metal. And the other element in our circuit is a variable voltmeter. And what's really important here is that we can change not only the value of the voltage but the polarity. So we can either make this side positive, in other words this side positive, or we can make this side negative. So we can change the polarity, which is important when determining the kinetic energy of the ejected electrons. Okay, so basically the photoelectric effect is a relatively simple idea, or maybe deceptively simple. And the idea is simply that we have some incident light coming in this case it's red light, and it's striking this metal plate. And if the light has enough energy, it will actually knock out electrons from the metal plate. And those electrons, if they have any kinetic energy at all, will jump across this gap, and as a result will run around the circuit, and we will read that as a current. And the more electrons that are knocked out in 1 second, the more electrons are going to run around this circuit, and the higher our current. So that's the basic idea of the photoelectric effect. Just a couple of other final points before we move on to our second screencast, and that is that the metal here on this plate, we are able to change the metal. Now, some of the common metals that we used were calcium, zinc, and magnesium. So they're three, and potassium, by the way. So they're different metals, or four of the metals that we use in this experiment. And what's important to know is that with these metals, they hold on to their electrons to different degrees of tightness. So depending on the atomic structure of the metal and how tightly the electron is bound to the nucleus, and also what shell the electron is in, all of those things determine how much energy it takes to knock an electron out of one of those atoms. And so that's something to keep in mind when we're looking at the results of the photoelectric effect. Okay, so just to sum up, the idea was that it would shine light on this metal plate. Sometimes electrons would be knocked out, other times they would not. If an electron is knocked out, it goes to the other plate, and if it reaches the other plate, it will then go around the circuit, and we will measure it as a photocurrent. Okay, that's the introduction to the photoelectric effect.